This chapter 5, section 6 is dealing with parallel and perpendicular lines. So our objective is to determine whether lines are parallel, perpendicular, or neither. And then finally, write equations of parallel lines and perpendicular lines. So the first thing is that we make sure we understand what both of these things are. So parallel lines you may have had some experience with, but it is important that you understand this is that two distinct lines in the coordinate plane either intersect or are parallel. So parallel lines are lines in the same plane that never intersect each other. All right. Now I'd also suggest that you write this down and get that picture in there. So if there are two lines that never intersect, like this red line here and this blue line here, what is true about their slopes? Well, if you've already read this, it means that they have the same slope. So lines that are parallel have the same slope, which makes sense. A slope is just its incline. So if they have the same incline, they should never touch each other. Okay. So if we know that, we can use that information to help us write an equation of parallel line. So we have some line that passes through 12, 5, and it's parallel to the graph of this. So we have this graph, which this would be our y-intercept at -1, and our slope is up 2 over 1, 1, 2, 3. So right about there. So we have a line that looks like this. Okay, that's this one right here. And we have another line that passes through 12, 5. So 12, 5 is 12 over and 5 up. So somewhere around here. There's another line that passes through this point, and it's parallel to this guy. So that means it's going to look something like this. We are looking for that equation in slope-intercept form. So how do we do that? Well, what do we need to know in order to write an equation in slope-intercept form? We need the slope, and we need at least 1 point. Okay, well, we got our 1 point right here, so that's easy. But how do we get our slope? What do we know about slopes of two parallel lines? We know that they are the same. So if this line right here has a slope of 2/3, our new line must also have a slope of 2/3. And here is our point that it goes through. And now this is just back to section 3. You're given the slope, you're given a point, find the equation. Now you can do this in two different ways. You can do this straight with slope-intercept form, or you can do it in point-slope form. So I'm going to do this two different ways just to show you. You pick which one you're more comfortable with. So the first one would be staying in slope-intercept form. So I'm replacing my y with 5. My slope I know is 2/3. I'm replacing my x with 12 plus b. I don't know what b is. So I got 5 equals 2/3 times 12, that's 8. Subtract 8 from each side, we get -3. So therefore, my formula is, or my equation is 2/3 x minus 3. Okay? If I decided to do this in point-slope form, I'm going to erase all of this right here. What I would do is I would start with y minus 5 equals 2/3 times x minus 12. That's my x value. And I distribute, so I get 2/3 x, 2/3 times minus 12, we have -8. I would then take this and add 5, which means I -8 plus 5, and I get -3. Same thing, two different ways. You pick which one you're more comfortable with. Next up is perpendicular. So perpendicular are two lines that intersect and they form a 90-degree angle. Okay, they make it like a perfect corner. Those are perpendicular lines. So perpendicular lines have slopes that what we call opposite reciprocals. So I don't feel like this is a very good explanation of what perpendicular lines are. I suggest that you have a picture, but it says two non-vertical lines are perpendicular if the product of their slopes is -1. So it's kind of a way to check. But what is important is you understand that a vertical line and a horizontal line are perpendicular. That is definitely something I would add to your notes. So in your notes, I would put this example, but I would put it after. Never mind. If you have this entire little paragraph here, you'll be okay. So two numbers, or two graphs, two lines that have slopes that are opposite reciprocals are perpendicular to each other. So what an opposite reciprocal is, let's take the reciprocal first. If you have a slope of 2/3, the reciprocal would be just flipping it 3/2. But we're missing this opposite. The opposite means change the sign. So if it was positive 2/3 before, it is now negative. If it was negative before, it is now positive. So that's how you find the opposite reciprocal. So a line passes through the point 2, 4, is perpendicular to y equals 1/3 x minus 1. We want to write the equation of a line. So again, it doesn't, I guess, state whether it should be slope-intercept form or point-slope form, but we are writing the equation. And to do that, we need slope and we need 1 point. We are given the 1 point right here. Okay, we need to find the slope. So the slope of our current line is 1/3. That means the slope of our new line is going to be the opposite reciprocal. The reciprocal is 3/1, or just 3. And since this was positive before, it is now negative. Okay? Now that we've found the slope, we can plug this into our slope-intercept form. So instead of y, we're going to put 4. Our slope is -3. Instead of x, we're going to put our 2 plus b. So we got 4 equals -6 plus b. Add 6 to both sides and you get b equals 10. So now that we know our y-intercept, our final answer would be y equals -3x plus 10. Okay? So this is a lot of things that you've done in previous sections. The only difference is that we now have parallel and perpendicular playing into it. So you need to know a little bit about, a little something about what parallel lines are, what perpendicular lines are, and the slopes of each. Once you're able to do that, pick that part apart, it's pretty much the same thing as we have been doing in the previous couple of sections. Okay? If you have any questions, please let me know tomorrow.